In chapter 4, what we're going to be looking at is a relationship between two variables. So for the first time, we're going to have two different variables. We're going to have an X variable and we're going to have a Y variable. We don't have to use the letters X and Y, but that's typically what we do. And so we're going to try to see if there's some kind of a relationship between these two variables, X and Y. And really specifically in chapter 4, we're going to be talking about quantitative variables, not qualitative, quantitative variables. So we've talked before about explanatory and response variables. Back in chapter 1, we did that. So the response variable is the variable whose value can be explained by the value of the explanatory or predictor variable. So what we're going to be doing is we're going to be looking to see if we can find a relationship between the explanatory variable and the response variable. The explanatory variable will generally be what we refer to as the X variable. In algebra, it is the independent variable. And the response variable is going to be what we're generally going to refer to as Y. In algebra, we call that the dependent variable. So we're going to see, can we explain what Y is based on what X is? Now we do have a new term here, a predictor variable. I personally will tend to use the term explanatory variable, but a predictor variable is the exact same thing. It's just another term for explanatory variable. So we're going to be looking to see if there's a relationship between this X variable and this Y variable, the explanatory variable and the response variable. Now, to start off with, if we want to try to see if there's a relationship between the explanatory variable and the response variable, then we're going to usually start by creating a graph of that information. And the graph that we're going to create is called a scatter plot. A scatter diagram is a graph that shows the relationship between two quantitative variables measured on the same individual. Each individual in the data set is represented by a point in the scatter diagram. The explanatory variable is plotted on the horizontal axis, and the response variable is plotted on the vertical axis. An example will help with this, I think. So take a look at this example. And incidentally, this is directly out of the book. A golf pro wants to investigate the relation between the club head speed of a golf club, measured in miles per hour, and the distance in yards that the ball will travel. He realizes that other variables besides club head speed determines the distance a ball will travel. For example, club type, the ball type, the person golfing, the weather conditions, and so on. So again, this golfer wants to know, is there a relationship between how fast I swing the club, so the club head's speed, and how far the ball travels? But he recognizes that there are other variables besides the speed of the club head that could affect how far a ball is going to travel. And so we need to try to control those other things, like the style of the club, the brand, for example, that could affect it, the kind of ball, the person golfing. So all of those kinds of things need to be controlled. So to eliminate the variability due to these variables, the pro uses a single model of club and ball. So he's controlling that. He uses a single golfer, and he uses a clear 70-degree day with no wind. So he's controlling all of those things that might affect how far the ball goes besides the speed of the club head. The pro records the club head speed, measures the distance the ball travels, and collects the data shown in the table to the right. Draw a scatter diagram of the data. So again, when the club was swung at 100 miles per hour, the ball traveled 257 yards. When the club was swung 102 miles per hour, the ball went 264 yards. When the club was swung 103 miles per hour, then the ball traveled 274 yards, and so on. So we're supposed to create a scatter plot of this data. So again, this is like the first swing. So we have these two that go together. That's going to form an ordered pair. Second swing, these two go together. So that's an ordered pair. Third swing, fourth swing, and so on. So I'm just going to plot these 8 points. I've already set up the grid here. So I've got my scale here. The speeds ranged from 99 was the lowest to 105 was the highest. So I just went ahead and set that up here. And then the distances, the shortest distance was the 257 right here. And the longest distance was the 277 right here. So I needed to go from the 257 or something convenient just below that to the 277 or something convenient just above that. So that's why I've got my scales here. And now I'm just going to plot these points. So 100, 257 would be maybe around right there. So I plot that point. So I've got that point plotted. 102, 264. So 102, 264 would be maybe about right there. So I've got that one plotted. 103, 274. So 103, 274 would be maybe around there. So I've got that one plotted. 101, 266. 101, 266 is going to be maybe around there. 105, 277. 105, 277 would maybe be around in there. 100, 263. So 100, 263 would be maybe about there. 99, 258. So 99, 258 would maybe be there. And last but not least, 105, 275. So 105, 275 would be right there. So I have my 8 points plotted. So again, what we're trying to look for is a relationship. Is there a relationship between how fast the club is swung and how far the golf ball goes? Well, I should tell you, it's hard really to make a definitive decision when you have so few data values. Normally on something like this, if we were really going to do this experiment, let's say, I would probably not just have 8 points, I would have maybe 80 or 100 or even maybe 800 or 1,000 different data points that I would be looking at. So it would be a little more obvious if there's a relationship or not. It's kind of hard to tell sometimes when you only have a few data values. But now when we're explaining the concepts in a statistics class, you can also get lost if you have way too many data values. And so we're trying to keep this reasonable. So if you look from left to right, can you kind of see that this is going up? So that would seem to kind of indicate that maybe on average, if you swing harder or swing faster, the ball's going to go further. There does seem to be that bit of a trend here. Now, again, it's not a perfect trend, but can you see that general trend? As we go from left to right, the points tend to be going up. So it does appear that maybe there is some kind of a relationship here. Now, specifically, what we're going to be looking for in this class is we're going to be looking to try to determine if there is a linear relationship between the explanatory and response data. So would I be able to draw a line through this data that would describe, on average, how far a ball would go if I swing at a specific speed? And so that's coming a little bit later on. So I do have a last note on this page. In this case, it's pretty obvious what the explanatory variable is and what the response variable is, based on the goal of the research. it's not always that clear. Sometimes it's not going to be clear which variable should be considered the response variable versus the explanatory variable. So if that's the case, we will just have to choose one of them to be the explanatory variable and the other to be the response variable if we're looking for a relationship. So scatter diagrams show the type of relation that exists between two variables. Our goal in interpreting scatter diagrams is to distinguish scatter diagrams that imply a linear relation, a nonlinear relation, or no relation. So again, our ultimate goal for this chapter is to be able to find whether or not we believe there's a linear relationship between the explanatory and response variable. And then if there is a linear relationship, we'll want to try to figure out what that is. What line could I use to best describe that relationship? So if we get a scatter plot that looks something like this, we would say that it appears we have a linear relationship. Now the data is usually not going to be perfectly linear, but you can clearly see that this would be linear. In fact, we call this relationship right here a positive relation or a positive association. So what does that mean? Well, definition right here. Two variables that are linearly related are positively associated when above average values of one variable are associated with above average values of the other variable, and below average values of one variable are associated with below average values of the other variable. That is, two variables are positively associated if, whenever the value of one variable increases, the value of the other variable also increases. So if you're looking at this graph right here, as x gets bigger, y gets bigger on average. Now we can also have a linear relation such as this. So again, clearly this looks like we have a somewhat linear relationship here. This is a negative association. There is a negative relationship. So what does that mean? Two variables that are linearly related are negatively associated when above average values of one variable are associated with below average values of the other variable. That is, two variables are negatively associated if, whenever the value of one variable increases, the value of the other variable decreases. So in other words, as x is getting bigger, y is getting smaller. So it's linear because we have a consistent decrease. This is linear because we have a consistent increase. So again, a positive association is sort of the same as a positive slope. If you could visualize a line going through there, that line would have a positive slope. Same way, this line would have a negative slope. So this data has a negative association. So this would be two cases where we have a linear relation, positive and negative. Now we can also have a scatter plot that looks like this. Well, if the scatter plot looks like this, that's certainly not linear. If we have a scatter plot that looks like this, goes up, down, up, that's more like a drain pipe. That's clearly not linear. Now these two maybe do have a relationship, like this would appear to maybe be that the two variables have a quadratic relationship, and this would maybe be that the two variables have a cubic relationship. But we're not going to worry about these in this class. We would just say that we don't have a linear relationship and we would be done with it. We could also have a case like this. In a case like this, there's no relationship at all. So when there's no relationship at all, like notice here that small x values are paired with both small and big y values, and large x values are paired with both small and big y values. So there's no relationship at all here. So we would say no relation. So again, notice the difference in the way this is stated right here. Here, there may be a relation, it's nonlinear. Here, there may be a relation, it's not linear. Here, there's not a relation at all. So again, we're going to focus on the linear relations. Now, I've given next notes on how we can use our calculator and StatCrunch to create scatter plots or scatter diagrams. So if I bring in my calculator, I went to Stat and Edit, and in List 1 and List 2, I have the golf club data that we just plotted by hand. So the data that I'm showing right here in List 1 and List 2 is the data for the club head speed and the distance. Now, when you enter these data into the list, you do have to use two lists, and you have to keep them paired side by side appropriately. So the 100 has to be beside the 257 and vice versa. The 102 has to be by the 264 and so on. They have to be paired up correctly in our lists. Once you have the data entered into the list, we can create a scatter plot or a scatter diagram in the same place where we did histograms and box plots. So I can go to Second and Stat Plot. I'm going to choose a plot and turn it on. So in this case, the kind of graph that we're going to do is this first option. That is a scatter plot. I need to tell the calculator which list has the X values. So which has the explanatory variable? Well, my explanatory variable is in List 1, so I've got to change that to say List 1. Where are the Y variables? Where's the response variable? I put those in List 2. So I have to tell the calculator that. The last thing that I have to tell the calculator is what kind of mark do I want it to use in order to label the points. Usually in this class, we're going to have a relatively small number of points, probably never more than like 20, usually more like 10 or 15. So usually I prefer to use the square because that's the biggest one and it just shows up more. If you had thousands of data values, you might want to choose one of these ones that are smaller. That's up to you. If you have a colored calculator, you can change the color if you want. So if you'd rather make your points red instead of blue, you have that option to change. I'm fine with blue, so I'm ready to graph this. The only other thing I have to do is choose an appropriate window. So for my X's in this case, my X-min either needs to be the smallest X value or a convenient number just a little smaller than my smallest X value. Well, our smallest X value was 99, so I either need to make X-min 99 or a convenient number a little less than that. I'm going to make it 98. My X-max needs to be either the largest X value or a convenient number a little bigger than the largest X value. Our largest X value is 105, so I'm going to make my X max 106. The scale doesn't really matter, but I'm going to choose a scale of 1. That's just, again, how often you're going to see a tick mark. So going from 98 to 106, that's only a difference of 8, so a scale of 1 is appropriate. If I was going from 98 to 1006, then I would probably use a much larger scale, like 50 or 100 or something like that. Same deal for Y's. So our smallest Y value was 257 right here, this first. So I need to make my Y-min either 257 or a convenient number below that. Maybe I'll make it 255. And our Y max either needs to be the largest value, which was 277, or a convenient number a little bigger. I'm going to make it 280. And then, so we're going from 255 to 280. That's a difference of 25. So a scale of 1 would probably work. We would see 25 tick marks on the Y-axis, but I'm going to make it 5. So I'm going to see a tick mark for 255, for 260, for 265, and so on. So with that done, all I have to do is hit the graph, and there is my scatter plot. So I can see that we do, in fact, have the same basic graph that we have here. Now, I could also do this in StatCrunch. So I have this data in StatCrunch. So I am ready to create this scatter plot. So A scatter plot is a graph. So I'm going to go to graph and I'm going to choose scatter plot. Now again, our book uses the term scatter diagram. A scatter diagram, a scatter plot, it's the same thing. So I'm just going to select scatter plot. I get this window. I then have to tell StatCrunch which column has the X variable. Well, that is the one I called speed. Which column has the Y variable? That is the one I called distance. Incidentally, if the number of values in this column doesn't match the number of values in this column, I'm going to get an error. That's true for the calculator and StatCrunch both. They have to match up because we have to have ordered pairs. Other than that, I'm just ready to compute. So I just say compute, and there I get the scatter plot. If you want to know specific values, like if I hover over that point, that is the data value that's in the 6th row, and X is 100 and Y is 263 on that point. So, couple of warnings. One warning is we're looking for a relationship between the X variable and the Y variable. Sometimes, whether there is a relationship or not can be distorted by our scatter plot, depending on the scale that I use. So for example, if you look at this data here that I'm showing you in StatCrunch, if you look at the scatter plot, I could understand someone's argument that that doesn't look all that linear. Well, look what I can do. If I were to close that up and stretch this out, so effectively I am changing the scale of my graph. Would you agree that this new graph right here that I have looks more linear than my original? Clearly, these points look to be straighter. So my point is that the scatter plot by itself doesn't do a complete job of deciding whether we have a linear relationship. So in this particular case, I can make the data look more linear just by distorting my graph, or I can make it look less linear by spreading it out. So that's an issue. We need another way of being able to determine whether we have a linear relationship besides just relying on a graph that again could be distorted. Now, we don't want to intentionally distort a graph, but it can happen unintentionally. So it looks like there's not a relationship when there is, or more likely, it looks like there is a relationship when maybe there isn't. So let me come back to my notes. Just to talk about what we've done, I've shown you how to use both the calculator and StatCrunch to create a scatter plot. And I asked in the example to use technology to construct the scatter diagram using the golf data from the previous example. And so we've done that. I showed you how to do both the calculator and StatCrunch for creating scatter diagrams. Now, caution. The horizontal and vertical scales of a scatter diagram should be set so that the scatter diagram does not mislead a reader. So again, that's along the same line of the point that I was making, that I can distort and make things look more linear or less linear. And we want to avoid that if we can. So numerical summaries of bivariate data should be used in addition to the graphs to describe any relation that exists between the two variables. So again, the second part is making the point that I was trying to say before. The scatter diagram by itself is not going to be enough to conclude that there's a linear relationship or there's not a linear relationship between the two variables. In addition, we're going to need to use some statistical calculations to help with this purpose.